So, hello, a very good afternoon to all. My screen is visible to all of you. एक बार कंफर्म कर दो फटाफट, मेरी आवाज भी सबको आ रही है क्या? कंफर्म वंस एंड उसके बाद हम लोग अपना स्टार्ट करते हैं, ठीक है? ओके राइट ओके JN विश्व होगा. ओके 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 थैंक यू फॉर योर कंफर्मेशन. Okay, so in today class, what we are going to do now, basically, we'll try to cover all revise the chemical properties that is left yesterday, and try to solve numericals related to this halogen compounds. Numerical, or we say the PYQ questions, because these are the organic chapters, so they can't contain any numericals, right? So basically, the conceptual and we can say that the question from the chemical properties or the physical properties or method of preparation. So we are going to see some numericals of the JEE Mains Advanced and NEET level, right? So let's start with the today class. For those who joining only for the today class, right? So let me discuss with you that we are revising haloalkanes and haloarenes. So in the first class, we cover all the method of preparation and the physical properties of both haloalkane and haloarene. And in today class, we are going to see the chemical properties and some important questions. ठीक है? तो चलो शुरू करते हैं. जिसको जहां भी कोई भी डाउट हो, anyone having any kind of doubt, you can ask me, right? Either by just in the replying in the chat box, or you can just unmute yourself and ask me about. No issue. चलो तो शुरू करते हैं. So first of all, it's very important thing that if I'm talking about the chemical properties of the halo compound, right? So these halo compound can undergo following type of reaction. How many type of reaction, beta? That is the substitution reaction, reaction with the metal, elimination reaction, and last but not the least, that is the reduction reaction. So out of these four, the three reaction, that is the substitution and reaction with metal and elimination, these three reaction are very important part of this chapter, and many questions were directly coming from this thing, right? So these three chapters are very important. Now there are some reduction part of also there, halo compound. So we are going to see these four type of reaction in detailed way. So let's study the substitution reaction first. As the name suggests, substitution. Substitution means what? So let's study this thing, right? So what is substitution, beta? Like as you can see, substitution reaction are those in which an atom or group of the atom from the reactant molecule is displaced by the another atom or a group of the atom. Right. So these are called basically the substitution reaction. So substitution reaction are those in which an atom or the group of atom from the reactant molecule is displaced by the another atom or a group of the atom, right? For example, let's say we have a CH3 and Cl, and let react this with KOH, right? Let react with this KOH. What happened now? This Cl, right? That is, this Cl is replaced, and instead, in place of this Cl, this OH comes at this point. So this type of reaction, this will form what? This will form CH3 and OH plus KCl. So these are the example of the substitution reaction. Later, we are going to study the differentiate between the nucleophilic substitution and electrophilic substitution. But I'm just trying to explain you what is substitution. So this is substitution. इसको हम क्या बोलेंगे बेटा? Substitutions बोलेंगे, ठीक है? Now, for example, just like on treating chloroethane with the sodium hydroxide, we get this. So this is an example of substitution reaction. So I hope यहाँ तक तो सबको clear होगा. बहुत simple चीज है, तुम लोगों ने पढ़ा भी है. So it's very much clear. Okay. Now, in substitution reaction, it is very important to note that is in case of the previous example, that is OH came and combined with the CH3, right? So in this reaction, it is noted that the hydroxide ion, that is OH, which act as a nucleophile and displace the chlorine atom from the ethane chloride, or in a as a substitution, or we say nucleophilic substitution reaction. So in the previous reaction, which act as a nucleophile, beta? That is OH negative hydroxide ion act as a nucleophile, and they displace the chlorine atom from C2H5 as a chloride ion, or we say another nucleophile, right? Such reaction which are initiated by the attack of nucleophile are called nucleophilic reaction. So always remember at this point beta, जो भी reaction जो initiate होते हैं by what? By the attack of nucleophile are known as nucleophilic reaction. Always remember this point, right? So basically haloalkane और haloarine जो होते हैं ना, like haloalkane and haloarine, they generally undergo nucleophilic substitution reaction. So always remember this thing, right? So in haloalkane, the carbon atom carrying the halogen atom is electron deficient. Why? Why electron deficient? Can anyone tell me? Why alkyl halide, the carbon become electron deficient? Why in haloalkane, the carbon carrying the halogen atom behave like a electron deficient carbon? Can anyone wants to say anything on this? किसी को कुछ बोलना है ऐसा क्यों होता है? Haloalkane, we all clear with the haloalkane now? That is haloalkane is nothing but that is CNX bond, right? That is carbon and halogen bond. This is known as haloalkane. So the carbon in the haloalkane bond are behave as an electron deficient. Why? It basically because halogen, we all know that is halogen is a very good electron withdrawing group. So they have, due to the more electronegativity of the X, that is a halogen compound, either if I'm talking about the chlorine, fluorine, bromine or iodine, right? Carbon is bonded to more, very good beta, right? So GN which, this is Changal girl. Yeah, good beta. So the CX bond of the haloalkane, because halogen is a more electronegative, right? So what is electronegativity? So electronegativity is nothing but tendency to attract the shared pair of electron towards itself. So they having a strong tendency to attract the shared pair of electron, right? So that's why ये तो अपना इलेक्ट्रॉन ले गया X, तो कार्बन पे क्या हो गया? इलेक्ट्रॉन की कमी, they have a deficiency of electron. So वहां पे electron deficient हो जाएगा, right? So it is due to the minus I effect of the halogen atom. We all know now what is minus I and plus I. Plus I is basically for electron donating group and minus I basically for the electron withdrawing group. Always remember this thing, right? So this electron deficient carbon atom is susceptible to attack by a nucleophile. तो उस पे कौन attack करेगा? Nucleophile. Why nucleophile attack? Because carbon become electron deficient and they want someone to come and donate the electron. That's why nucleophile comes into the picture, right? Because the carbon behave as the electron deficient, or in other words, you can say that carbon become electrophile, they having deficiency of electron, right? So if they have a deficiency of electron, then definitely nucleophile come and donate its electron to the carbon atom. And by this, the nucleophilic substitution reaction takes place, right? So this is the pure principle behind this. This is the mechanism for the nucleophilic substitution reaction, right? So thus you can say that, or we conclude that in haloalkane, right? In haloalkane undergo nucleophilic substitution reaction, right? So we can say that haloalkane undergo nucleophilic substitution reaction, right? Now let's see some example of the nucleophilic substitution reaction, and these examples are very, very, very important, right? In terms of either your CBSE exam point of view or JEE or NEET or advanced, right? So these examples are very important to understand. So let's see the example. For example, when the alkyl halide is treated with the base, for example, if they are treated with the potassium hydroxide, NaOH, any type of base, then what will this OH negative, that is hydroxide ion, they act as a nucleophile. So they attack to this carbon R, so alcohol will be formed. Similar, when the ammonia is treated with the haloalkane, then amine is formed, that is alkyne amine. Similarly, when the KCN is treated, right, then CN negative, they behave like a nucleophile, then RCN will be formed. Similarly, when SH negative act as a nucleophile, then RSH is formed. Similarly, when RNH2 is reacted, then RNHR will be formed. That is called secondary amine, right? So these all are the example of the nucleophilic substitution reaction, right? So I hope this is clear to all of you. Nucleophilic substitution reaction, jaldi batao. In all the above reaction, the stronger nucleophile, Okay, if someone asks, can you name some stronger nucleophile? Just remember the name. Like OH negative, C2H4, O negative, Cn negative, or NH3. So these are basically the stronger nucleophile and displays the weaker nucleophile like X. Halogen itself behave like a nucleophile, but they are weaker nucleophile. So they displace the weaker nucleophile. Thus, we can say that they must be strong, right? Right? Clear hai? Chalo. Now, the nucleophilic substitution reaction, what is the mechanism behind this? What is difference between SN1 and SN2? What is this SN1, SN2? So basically, SN1 stands for nucleophilic substitution of order 1, or we say unimolecular. Similar, SN2 stands for the nucleophilic substitution order 2, also known as a bimolecular reaction. ठीक है यहाँ तक? यानी when the nucleophilic attack the haloalkane and simultaneously the living group leaves, then the reaction called nucleophilic substitution bimolecular. मतलब एक ही समय पे अटैक हो रहा है और उसी समय पीछे से एक न्यूक्लियोफाइल अटैक कर रहा है और आगे से एक न्यूक्लियोफाइल निकल भी रहा है. So that is called bimolecular reaction. Why bimolecular reaction? Because if you study the chemical kinetics now, then you must understand this thing, that is rate of reaction is depend upon the reactant raised to the power stoichiometric coefficient, right? This stoichiometric coefficient find experimentally and also known as the order of reaction. We all know this thing? Good. So in this reaction, in the above reaction, as we can say that this is a OH. OH act as a nucleophile. So this is the nucleophile, right? So this nucleophile attack from the back, and this is the living group, right? This is the living group. So this both thing, that is leaving the carbon atom and attacking on the carbon atom, both taking place at the same time. So we can say that this is called biomolecular nucleophilic substitution reaction, because here the rate of reaction depends upon the alkyl halide as well as the nucleophile, how strong nucleophile are. If the nucleophile are weak, अगर न्यूक्लियोफाइल हुआ वीक, तब तो वो हटा ही नहीं पाएगा आगे से क्लोरीन को. तो जब वो हटा ही नहीं पाएगा तो पीछे से वो डोनेट कैसे करेगा? सो इट इज ऑलवेज नोट इन योर माइंड बेटा that in case of bimolecular or SN2 reaction, always stronger nucleophile recommended, right? Because stronger nucleophile are only able to make this transition state happening, right? So always remember this thing better, right? So here we need strong nucleophile so that weaker nucleophile can be become good living group, right? Here transition state is occur. So if someone asks in SN2 reaction, transition state occur or not, so always remember in SN2 reaction, transition state is occur. So we can say that now for the fraction of time, I'm not saying that it's always true, but for the fraction of time, we can say that carbon having 5 valency, because we all know carbon having 4 valency, right? We all know carbon having 4 valency, it will make only 4 bonds. But in transition state, can you observe that for the some fraction of time, carbon having 5 valency, right? 1 with the chlorine and 3 with the hydrogen, 1 with the OH group. So in the transition state, for the some fraction of time, carbon also show valency up to 5, right? So they show valency up to 5. 5 bonds are formed by the carbon, right? And later Cl is removed and we'll get our product, that is the alcohol, right? So also note that it is in a one-step process and the transition state involved in the 2 species. So it is a one-step process and the transition state involved the 2 species. That is the formation of this transition state is the rate determining step. So we all know that what is rate determining step? Rate determining step is the slowest step. Always remember, rate determining step is the slowest step and the rate of reaction only depend upon the RDX. That is the rate determining step, RDS, right? Now, here the bond making and the bond breaking takes place simultaneously. Yani at the same point, bond is making and the bond is also break. The nucleophile, that is OH, attack from one side of the carbon atom whereas the living group Cl lift from the opposite direction. Hence, there is an inversion of the configuration. So always remember this point. In case of SN2 mechanism, we get the inversion of the configuration at the carbon atom. So in some question they are asking in SN2 or SN1, in which you will get the inversion of the product. Always remember this. In case of SN2 only will get the inversion of the configuration. सबको क्लियर है यहां तक? जल्दी से एक बार कंफर्म कर दो, फिर आगे चलते हैं फटाफट. सबको समझ आ गया? Or anyone having any kind of doubt till you can ask. Shall we move? Yes, beta. Shall we move now? Chalo. Okay. Now, primary alkyl halide undergoes substitution reaction by the SN2 mechanism. Very good as compared to the 3 degree, 2 degree or 1 degree. So the order of reactivity for the SN2 is nothing but 1 degree, then 2 degree, and then 3 degree. Can anyone explain why the order of reactivity is like this for SN2? Because in SN2, back attack is taking, right? Or we say जिस टाइम पे अटैक हो रहा है उसी टाइम पे न्यूक्लियोफाइल बाहर भी निकल रहा है, यानी both the processes are take place at the same time. So if we have a tertiary alkyl halide, right? Let us consider this is a tertiary alkyl halide. Okay. So if we have a tertiary alkyl halide like this, then back attack is very very difficult, because here 3 bulky CH3 group are there. So if the 3 bulky CH3 group are there, then the attack become very difficult, right? But in case of primary alkyl halide like CH3, we have like 1H, we have 1H, we have 1 which and this is a Br. So the size of this H atom is very, very small. So in this, the attack is very simple, right? But in case of the tertiary alkyl halide, we can say that due to presence of 3 bulky CH3 group, back attack is not possible. It is very difficult, right? That's why the order of reactivity for the SN2 reaction, generally, I'm talking about SN2, is 1 degree, 2 degree, and 3 degree, right? Now, let's see the SN1 reaction so that you can differentiate between these two, SN1 and SN2, right? So on the other hand side, if I'm talking about the SN1 reaction, that is the nucleophilic substitution of order 1, or we say is a unimolecular reaction. So these are formed by the formation of carbocation, right? These are formed by the formation of carbocation. As we can see that this being the tertiary alkyl halide, and when the electron withdrawing group such as the bromine attached to this, the bromine having a tendency to shift the electron towards itself because they are more electronegative, and they want to take the electron, and the heterolytic fission will be takes place. So due to this, when the bromine takes away its electron, heterolytic fission takes place. So carbon having deficiency of electron and carbon having positive charge. Now I tell you the situation. If I have 1H group, 1H, 1H, and carbon become positive. This is also carbocation, methyl carbocation. Now, if we have carbocation like this, 1 degree carbocation, right? If we have a 2 degree carbocation, 2 degree carbocation like we have a CH3, and this is CH positive. So out of these 3, right, this is the number 1, this is the number 2, this is the number 3, and this is the number 4. In which of the following given structure, carbocation is more stable? Can you tell me? Carbocation means deficiency of electron. So they want some donor group to with them, right? If some donor group are present with the carbocation, then definitely this carbocation feels good, because they want someone to donate their electron. So if I'm talking about the tertiary carbocation, this is the tertiary carbocation. So in this 3 donor group is present, that is 3 CH3 group, as we can say that there is a 3 CH3 and 3 donor group is present. So this carbocation is very, very stable. On the other hand side, this carbocation, because there is a no donor group is present, because the electron activity of hydrogen and carbon are almost same. So we can say that there is a no donor group is present. So what we can say? We can say that in such cases, the carbocation having very less stable. So if I'm talking about the SN1 mechanism, because SN1 mechanism happens through the formation of carbocation, and we know that which carbocation is much more stable, that is as tertiary, that is 3 degree. So the stability become 3 degree, 2 degree, and 1 degree, right? So always remember these two things. If I'm talking about the reactivity order of the SN2, it must be 1 degree, 2 degree, and 3 degree, because in the transition state is formed. If the bulky group is present, then back attack is not possible. Now, if I'm talking about the SN1, then this is formed by the formation of carbocation, and we know that the 3 degree or the tertiary carbocation is much more stable as compared to the primary or the methyl carbocation. Therefore, the order of substitution is 3, 2, and 1 degree. So I hope यहाँ तक सबको clear है. किसी को कोई भी डाउट हो बेटा जल्दी पूछो फटाफट. यहाँ तक किसी को कोई भी डाउट है अभी तक? यस नो क्लियर है? हाँ भाई सबको क्लियर है ना? चलो. So this is all the mechanism, right? हाँ किसी ने लिखा है? Yes, clear sir. Very good बेटा. चलो. So after this, as soon as the carbocation is formed, nucleophile, which is a water solvent. So in this case, na carbocation is formed. So carbocation doesn't need a specific type of nucleophile. What do you mean by this term specific file? Specify means in this maybe weak nucleophile or strong nucleophile. So both are okay, right? Both are react easily, because in this the carbocation is formed and carbon wants some nucleophile to come and attack, right? Once more, sir. Yes, JNV Simoga. Once more, which one, beta? कौन सा समझना है बताओ जल्दी एक बार. Right, I am talking about the SN1 and SN2. Okay, so in SN2 reaction, now what happening in SN2? Because SN2 reaction, back attack is takes place. Therefore, if we have a bulky group like a tertiary alkyl halide, then this attack is not possible, right? Because CH3 group is very big. So we prefer here primary alkyl, because in this only one CH3 group is there, or we say methyl chloride, only there's no bulky group is present, only a hydrogen is present. So the back attack is possible, right? So and the inversion of product is also formed. So we can say that the reactivity for the SN2 is nothing but 1 degree, 2 degree, and 3 degree. Now, if I'm talking about the SN1 reaction, so SN1 reaction is formed by the formation of carbocation, and the tertiary carbocation, this is much more stable. Why this is much more stable, beta? Because in this 3 donor group is present. So this 3 donor group can donate the electron and carbon feel good, because they have a 3 donor group with them. So they are much more stable as compared to the methyl carbocation, because they are having no donor group. They behave as a carbocation, but they do not have any donor group to donate the electron. So therefore, the reason in case of the SN1 mechanism, 3 degree will be the highly stable, or we can say that the reactivity of the 3 degree is very much, right? And one important thing is, in case of carbocation, they do not require any strong type of nucleophile. They require any type of nucleophile which can attack, right? So here we can say that this is the tertiary carbocation and this is in a water which act as a nucleophile. So this O attack to this carbon atom and the formation of alkyl oxonium will takes place, right? Now this alkyl oxonium loses the proton to give alcohol as the product, right? So we'll get this product like a alcohol. So SN2 reaction proceed via the formation of carbocation, and the stability of the carbocation formed is an important factor in the SN1 reaction. So what is the stability of the carbocation? We all know tertiary carbocation is much more stable. So that's why the stability of the tertiary reactivity of the tertiary is much more as compared to the primary, right? So ये भी clear हो गया सबको? चलो. Now, haloarenes. Now we are talking about the haloarenes. We're done with the haloalkane. We're done with the that is the substitution reaction and all. Now let's see the haloarene. So haloarine are almost unreactive to the reagent such as the NaOH, C2H5ONA or NaCN. So we can say that now this will undergo they have a very less tendency to undergo nucleophilic substitution reaction, right? I'm talking about the haloarine. So haloarine are almost unreactive. Why? Because like haloalkane now, they are not electron deficient. They itself having electron donor group. So they want some electrophiles to come and attack on them. But however, in some drastic condition, or if you apply some case like if you apply some electron withdrawing group to the benzene ring, then it must show. Then maybe it show nucleophilic substitution. But the tendency to show nucleophilic reaction in the haloarine are very less, right? So haloarenes are almost unreactive to the reagent, and this under the ordinary laboratory condition, but can show nucleophilic substitution reaction at a drastic condition. What is this drastic condition? Can anyone tell? What do you mean by this some drastic condition? Anyone? What is this drastic condition, beta? Huh? So drastic condition means at very high temperature and pressure, right? So if the pressure and temperature is very, very high, then we can say that it is very, very important name reaction when we treat chlorobenzene with the 6 to 8% of NaOH and at the 623 Kelvin, right? High temperature, pressure, and use of the catalyst. Very good, beta, right? So when we use the 6 to 8% of NaOH and 623 Kelvin or the 300 atm pressure in the presence of dilute HCl. So condition is temperature is very high, 623 Kelvin, pressure is also very high, 300 atm, and by using some catalyst. So this chlorobenzene undergo nucleophilic substitution reaction to form this phenol, right? So this method is very important because in the method of preparation of phenol, we also use this method, or in the chemical properties of chlorobenzene that we are using already, right? So it is also observed that the presence of electron withdrawing groups such as NO2 group at ortho and para position, not at the meta position, with respect to the halogen, activate the halogen atom towards the nucleophilic displacement reaction, right? For example, let's see some examples so that the concept become clear, right? So if someone says, will chlorobenzene undergo nucleophilic substitution reaction? Then, we can say that yes, it will go, but under the very drastic condition. In the normal condition, they will go. No, it won't go nucleophilic substitution reaction at the normal condition. Now, what happen if we put one NO2 group to the benzene ring at the ortho and para position? So, if we put one NO2 group, then this reaction undergo very easily, right? Like just at the 433 Kelvin and the normal pressure, like 623 through just 423. So, here we need just 433 Kelvin of temperature in the presence of 15% of NaOH and dilute HCl. It will form 4-nitrophenol. So, it is only due to presence of this NO2 because this NO2 acts as a बताओ जल्दी this NO2 act as an electron withdrawing group. So अब इससे क्या होगा? If they behave like an electron withdrawing group, so they continuously absorb electron from this chlorine group and make this ring make this ring become electropositive, right? Make this ring become electropositive because the electrons are withdrawing by the NO2 group. So only nucleophile come. By nucleophile क्या होता है? Nucleophile है इसको electron donate करना है. So if nucleophile wants to donate electron, so whom they wants to donate electron? Those who want electron, right? Nucleophile cannot donate electron to those who already having electron, right? So nucleophile donate electron to those only who want electron, and who want electron which having some electrophilic behavior, right? So that's why NO2 group is attached here, because this NO2 group act as an electron withdrawing group, and they continuously withdraw electron from this ring, and the ring become right. They make the ring reactive, right? And that's why this reaction will take place. Now, what happened? Similarly, what happened if we have, right? Let me show with an example. What happened if we have one NO2 group is here, one NO2 group is here, and one NO2 group is here. Can anyone tell me what happened? Well, at this, how many, what is the temperature and pressure? Whether they require a more temperature than 433 Kelvin, less than 200, or we say just by boiling, right? If they undergo nucleophilic substitution reaction with the NaOH, right? In presence of dilute HCl, right? So they will form, this is OH, right? And this will be NO2, NO2, and NO2. Yes, someone faster reaction, low temperature and pressure. Right, beta. Very good. So this reaction takes place even at the boiling temperature, right? It means just if we have a boiled water, then also this reaction will take place. So this reaction will take place at just a normal boiling temperature. So in this, we won't require any 433 or 623 Kelvin of temperature. So as we can say that as the number of electron withdrawing group increase, the reactivity towards the nucleophilic substitution also increase. So we can say that haloarenes can also readily undergo substitution reaction in the benzene ring. Right, the benzene ring is an electron-rich species. Therefore, it is attacked by the electron-deficient species such as the NO2 plus. As ortho and para position in the haloarenes are electron-rich due to the resonance. We all know that, and we are going to study also this thing. That is the ortho and para position of the haloarenes are electron-rich. Why? Because due to resonance. So due to resonance, the delocalization of electrons take place and the electron density is more at ortho and para position, right? So at the ortho and para position in the haloarenes are electron rich due to the resonance. The electrophilic substitution takes place mainly at this position, right? For example, the nitration of the chlorobenzene with a mixture of concentrated NaHO4 as 2SO4 give a mixture of 2 nitrobenzene and 4 nitrobenzene. So here we can say that. So this is, we are talking about the electrophilic substitution reaction. So here, till here only we have a nucleophilic. From here we have a electrophilic substitution reaction. So when you treat chlorobenzene with a concentrated HNO3 and concentrated H2SO4, then the formation of ortho-chlorobenzene and the para chlorobenzene will be takes place, right? That is the 2 nitrochlorobenzene and the 4 nitrochlorobenzene. So the reaction will be takes place, right? So these all about the reaction. So just like a nitration, we have a reaction like a halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation. So all this reaction takes place at ortho and para position only, right? So this all reaction takes place only at the ortho and the para position. Now, let's see the energy differences. If we're talking about the CF bond energy, 485, CCl bond energy, 339, CBr and Ci. So we can see that as we move down the group in the halogen series, that is from fluorine to iodine, right? Fluorine to iodine, the bond length become increases and the energy become decreases. Obviously, if you want to break this pen, then you can break this easily. Now, if you want to break a cap of this pen, right? Only this portion of this pen, then this is very difficult to break. So as the size increases, as the bond length increases, then definitely bond strength will be decreases. So these bond energy values show that the C1 bond is the weakest bond and CF bond is the strongest bond. Therefore, the order of reactivity of haloalkane is iodoalkane, bromoalkane, chloroalkane, and fluoroalkane, right? So comparing the haloalkane and haloarenes, haloalkanes are found to be more reactive. So always remember this point. This type of questions are coming, many times in your board exam itself. Always 2 marks questions are coming out of haloalkane and haloarene. Which one is more reactive? So you simply say alkyl halide, haloalkane is more reactive than haloarene. And why this is? So there is a reason behind it, right? So why haloalkane are more reactive than haloarenes? So haloalkanes are found to be more reactive than haloarenes in the reaction involving the breaking of CX bond. Why? Because in haloarene, due to the resonance, as we can say that due to the resonance, the CX bond requires the double bond character, right? The CX bond requires a double bond character, which is difficult to break, which is not happening in the haloalkane, right? So due to the resonance, the CX bond acquires the double bond character, and due to this double bond character, the bond becomes strong and difficult to break. So this is the resonance diagram of a chlorobenzene. Chlorine is also a withdrawing group, right? So we can say that it's a meta-directing group. But why this is ortho and para-directing group, right? So this is also electron withdrawing group. So why we can consider chlorine to be electron donating group? Chal. Because chlorine having 7 electrons, or we can say that chlorine having 3 lone pair of electrons and 1 pair of electrons, right? So due to presence of the resonance shown by the chlorine, due to presence of resonance shown by the chlorine, they will make the bond, no, they will make the bond more strong, right? So the double bond is always stronger than the single bond. So this is all happening in case of what? In the case of a carbon halogen bond, right? Good. Now, if now we all successfully cover the which type of, that is substitution reaction. Now let's see. Now let's see the elimination reaction. So just give me a 1 minute and we'll start with the elimination reaction. Right? Just give me 1 minute. Right. So let's see the elimination reaction. So guys, anyone having any kind of doubt in substitution reaction? किसी को कोई डाउट है क्या? पूछना है कुछ आप लोगों को सब्स्टिट्यूशन रिएक्शन में? नो? चले एलिमिनेशन की तरफ? चलो. So हमने क्या क्या पढ़ा? What is substitution reaction? Different type of substitution reaction, that is SN1 and SN2. Whether the substitution reaction will be takes place in the aromatic compounds or not. What is the way to introduce the substitution reaction in the aromatic compound, right? So, and what is the electrophilic substitution reaction in the haloalkane? So these we already covered. Now let's see the elimination reaction. So as the name suggests now, as the name suggests, what is elimination reaction? So when the haloalkanes are heated with the aqueous solution or potassium or the sodium hydroxide, the major product formed is the alcohol, right? So whenever the haloalkanes are heated with the aqueous solution of potassium or sodium hydroxide, the major product formed is the alcohol and produced by the nucleophilic displacement of the halogen atom by the HO. So let's see this. So this is the, this is the chloroethane. And with this treat with the aqueous KOH, what is formed? Ethanol and chlorine negative. Now, what happens if the haloalkane is heated with a concentrated alcoholic potassium hydroxide? So here, a beta elimination or we say elimination reaction comes into the picture. So when you treat with the aqueous KOH, then it's a simple nucleophilic substitution reaction. There is no use of elimination and all. But if the haloalkane is heated with a concentrated alcoholic potassium hydroxide, then the major product form is alkene. And due to the elimination of hydrogen halide, and this is also known as the beta elimination or we say dehydrohalogenation. Let's see the example. So we have a chloroethane, right? We have a chloroethane like C2H5Cl. And when we treat with the chloroethane with the alcoholic KOH, then what will form beta? Form this is ethane will be formed. So in this reaction, the OH negative ion, remember this point beta, very important. So in this reaction, the OH negative ion act and a base remove a proton. Always remember, ion act as and a base remove a proton from the molecule. So this OH, right? This OH act as a base and remove a proton from the molecule and wants to remove a proton from the molecule. So from where they will remove? We have a CH3, we have a CH2, and we have a Cl. So this is the alpha position and this is the beta position. So from the beta position, they remove H, right? So we can say that base remove a proton from the molecule. So if the structure of the alkyl halide is such that it can undergo elimination in the two different ways, then the more highly substituted alkene having the lesser number of hydrogen atom on the doubly bonded carbon atom is the major product in the elimination. And this is also known as the Sirjeff rule. So let me explain with the example, right? So Sedgwick rule. So let us assume that if I have two bromobutane, right? So if I have two bromobutane, that is CH3, CH2, CHBr, and CH3. So if I have two bromobutane, and someone asks what happen if they will undergo alcoholic KOH reaction, right? So two bromobutane, this will give the two major products. The first is KBr is removed, there is no problem in this. But this OH negative, right? This OH negative, they want a base. They act as a base and accept a proton. So from which, because this is a group. So this carbon is the alpha carbon. So this is also the beta carbon. This is also the beta carbon. So let us assume if you remove H from this carbon, right? That is the beta first one. So we'll get this, right? Now, similarly, if we remove from this beta position hydrogen, if we remove one hydrogen, we'll give this. So according to the Sidjev rule, the maximum product is formed by those which having the lesser number of hydrogen on the double bond. For example, if we, if we cover this thing, so we can say that across the double bond only we have a two hydrogen, but along this we have two hydrogen for this carbon atom and only one hydrogen for this. So more having more number of hydrogen atom. Or in other words, you can also say that here we have a two donor group, right? We have a two donor group. One is a CH3 and another is also CH3. But here we have only one donor group, right? Only one donor group. So you can say either of this. So all these are correct one, right? So these all are the correct explanation. I hope this is clear. समझ आया क्या ये वाला जल्दी बताओ एक बार फटाफट the how major and minor product will be formed. So when we treat two bromobutane, we have a two product. When we treat with alcoholic KOH, one having the called butene, which is in a 80% or we say major product, and the another is a but1ene that is a 20%, right? So these two type of reaction we got in this alcoholic KOH, right? And this is also known as the beta elimination reaction. So let's move towards the end of this chemical properties. That is the last reaction that we are going to discuss. That is the reaction with the metals, right? So basically, haloalkanes and haloarine react with a variety of metal, that is the zinc, magnesium, and lithium, and the compounds so obtained have a metal atom directly bonded to the carbon atom. Such compound in which the metal atom is directly bonded to the carbon atom are called organometallic compound. Always remember, if someone asks what is organometallic compound, so what you have to say, beta, the such compound in which the metal atom is directly attached, right? In which the metal atom is directly bonded or directly attached to the carbon atom are known as a organometallic compound, right? And the organometallic compound of magnesium alkyl and alkyl halide are also known as Grignard region. For example, we have a chloroethane. When they react with the magnesium in the presence of dry ether, they will form ethyl magnesium chloride, also known as the Grignard region. So this Grignard region play a very significant role in the carbonyl compound or alcohol, because many of the aldehyde and ketone, they react with this to form the different product, or by using aldehyde and ketone, by using Grignard region, with some other element, we can also produce aldehyde and ketone. So these Grignard will play a very significant role, right? Now, on the similar basis, alkyl halide react with the metallic sodium, just like the magnesium. They also react with the metallic sodium in presence of dry ether to form symmetrical higher alkane. And this is known as the Wurtz reaction. So always remember this. This is known as the Wurtz reaction. So for the Wurtz reaction, we have a chloromethane. Then they react with the 2NaCl to form a ethane, right? So chloromethane combined to form ethane, and the chloropropane combined to form hexane. So always twice the number of, if in the reactant we have a 3 carbon, then in the product we'll get the 6. So this reaction is always used for the doubling or increasing number of carbon atom. If you want to convert the atom from one way to another way, then you can use this Wurtz reaction. So the ethyl bromide can react with the lead in presence of dry ether to form tetraethyl lead, which is used as an anti-knocking agent in a gasoline used for the running automobiles, right? When haloarenes are reacted with the alkyl halide in a presence of a sodium and Wurtz, dry ether, the alkyl derivative of benzene is formed, also known as a chlorobenzene. So this thing we already know. This is known as a Wurtz-Fitting reaction, right? This is known as the Wurtz-Fitting reaction. Why they are called Wurtz-Fitting reaction, beta? Because in this we have a one chlorobenzene, and this we have a CH3Cl. So this is also the example of a halogen exchange method, or we can say that. So this will form, right? So this toluene will be formed. Similarly, when the halogens are treated with the sodium diaryl product, the reaction is called Fitting reaction. For example, if someone says, how will you convert chlorobenzene? How will you convert chlorobenzene, right? How will you convert chlorobenzene into biphenyl? Then how will you convert beta? By using the Fitting reaction. So by the reaction with the metal, with magnesium, we have only one reaction, but with sodium, we have a three reaction. The first one is the Wurtz reaction. The second is the Wurtz-Fitting reaction, and the third one, third but not the last, that is the Fitting reaction. Clear? So this is all we have. Now let's move to the next and the last reaction of this chemical property, that is the reduction. So haloalkane can be reduced to the corresponding alkane. For example, bromoethane can be reduced to ethane by using the metal catalyst such as the nickel or palladium or platinum, or by using hydrochloric acid HI in presence of red phosphorus. So this bromoethane can easily converted into ethane by using a catalyst nickel or platinum. Right? So I hope this is clear to all of you. सबको क्लियर है यहाँ तक? ठीक है, चलो भाई, तो कुछ क्वेश्चंस कर लें क्या? पहले कुछ क्वेश्चंस कर लेते हैं, देन वी आर गोइंग टू और चलो पहले क्विकली रिवाइज कर ही लेते हैं पॉलीहैलोजन कंपाउंड को भी, देन देखते हैं क्वेश्चन का, ठीक है? So what is polyhalogen compound? So a large number of polyhalogen, these are basically theoretical concept of polyhalogen compound, right? So जल्दी जल्दी फटाफट इसको देख लेते हैं ताकि उसके बाद हम अपने क्वेश्चंस कर सकें. So a large number of a polyhalogen compound, है ना, and aromatic halogen compound are known. So these are extensively used as a solvent, pesticide, antiseptic, and some of important compound are the chloroform, iodoform, carbon tetrachloride, benzene hexachloride, right? BSC and the DDT. So let us now study some of this compound which is going to be very, very important. So now what is chloroform, right? So let's study first of all chloroform. So if you're talking about the chloroform, what is chloroform? Can anyone tell me? Can anyone tell me the formula of chloroform? So chloroform is nothing but the derivative of the simplest hydrocarbon methane, and the IPS name of the chloroform is trichloromethane. We have a formula like right CHCl3. So chloroform is a derivative of the simplest hydrocarbon methane, and IUPAC name is trichloromethane. So we have a 1 comma trichloro and methane. So this is the chloroform, right? So from ethanol, you can prepare. How will you prepare? So chloroform is prepared in the laboratory by treating ethanol or propanol with the chlorine gas. Ethanol and propanol with the chlorine gas in presence of an alkali. For example, when we oxidation of ethanol, when we treat ethanol with the Cl2, it will form ethanol, right? So and after ethanol, it will react with the 3Cl2 to form the trichloroethanol, also known as a chloral. Always remember, they are also known as a chloral. ठीक है भाई, चलो. So chloroform क्या क्या properties है chloroform की? Chloroform की properties क्या क्या है? So chloroform is a colorless, sweet-smelling liquid having boiling point 334 Kelvin. It is a slowly oxidizing by air in presence of light and to a poisonous gas. So it is very important point, beta. They are oxidized and undergo oxidation to form a light poisonous gas, pose gas, right? Pose gain. So how to do to remove this pose gain? So chemically, phosgene is a carbonyl chloride, that is CaCOCl2. COCl2. Therefore, the chloroform is stored in the dark colored bottle. So always questions were coming the previous year. Why chloroform is stored in the dark bottle? To prevent its oxidation, right? So therefore, the chloroform is stored in the dark bottle to protect it from light. The bottle are completely filled so that the air is kept out. Or we say the small amount of ethanol is added to the chloroform to convert the toxic for the gas, right? So this is a reaction for we have like a chloroform react with the O2 in the presence of sunlight, so they will form frozen gas plus HCl. Right. So this is about the chloroform. So chloroform is used in the isocyanide test for the detection of the primary amine. In this test, a mixture of amine and chloroform is heated with the alcoholic NaOH. So what happening better? Here we have a ethyl amine and here we have a chloroform. When they react with this, then what will form? That is ethyl isocyanide. So ethyl isocyanide will be formed. Now let's move to the next thing, that is the iodoform. So what is this iodoform test beta? Can anyone? So iodoform is a pale yellow solid with a distinct smell, and the IUPAC name is nothing but triiodomethane. 111, that is triidomethane. So what is the preparation? So iodoform is prepared by heating ethanol or acetone with the iodine in the presence of ethanol, right? So preparation क्या हो जाएगा ये iodoform का? So iodoform is prepared by heating ethanol, right? By heating, just wait. So ठीक है चलो. So iodoform is a pale yellow solid with a distinct smell, and the IUPAC name is nothing but the 1111 triidomethane. So how will you prepare? So iodoform is prepared by the heating ethanol or acetone with the iodine in the presence of alkali. So this is the iodoform test that we have generally used for the chemical distance between the alcohol or between the aldehyde and acetone. Right. So these tests, that is the iodoform test, we generally use in the first chapter. There's alkyl halide as well, in alcohol as well, in the aldehyde and ketone as well. Right. So all this thing we use this iodoform test. So remember very carefully, better. This is going to be very, very, very important. Always remember this iodoform test. How will you prepare this iodoform test? And yellow color of iodoform can be easily recognized by the characteristic smell. Formation of iodoform is used to test the compound containing CH3COOH. Right. So these all are the preparation of iodoforms. Okay. Now let's see the structure of the DDT. The DDT stands for the dichloro diphenyl dichloroethane. Right. So this is stand for the dichloro diphenyl trichloroethane. So this is the structure of the DDT, and it is used mainly to control the mosquito malaria. It is used as an anti-agriculture insecticide. The use of DDT has been banned in the many countries because being a non-biodegradable, it is accumulation and innovation. It is the toxic to the other living organism, right? So this is the example, or we can say this is the full form of the DDT. Okay. So these all are the summary reaction for you all. So these are the summarization for all the physical and the chemical properties of the alkyl halide. So just go through this, Hannah. Try to revise this thing. Try to watch this video again and again, and after this, try to solve the question. So revise this thing all. This is very important, and if you understand the concept, principle, and mechanism behind this one, then you can easily solve question related to this, right? So take care. This is all for the today class. Time is already done. So this is all for the today class. Try to learn as much as you can, okay? And try to just revise the answer. Anyone having any kind of doubt you can ask, or we shall close this. No doubt? सबको समझ आया आज हमने जो भी पढ़ा, ये बता दो. थैंक यू सर. ओके, मोस्ट वेलकम. ठीक है, चलो तो टेक केयर, और फिर नेक्स्ट क्लास से मिलते हैं, फिर वहां हम लोग करेंगे नेक्स्ट. ठीक है.